Welcome to Eugenius Panda Virtual Labs, where students and teachers access the virtual laboratory simulations for various science subjects.
Hey guys, welcome back. In this lesson, we will discuss the covalent bonding. In this lesson, we will discuss the polarity of molecules, part 1. It is a topic which is found in Senior 4 of A-level chemistry, according to Rwanda Education Board. And the unit is called Covalent Bonding and Molecular Geometry. The part 1 we will discuss today in this lesson is about bond polarity. We can't understand what it's all about, the polarity. We can't understand what means the polarity of molecules if we don't really understand the concept of bond polarity. So to understand the polarity of molecules and use the simulation, we are going to explain how it works. We need two important things: knowledge of polarity of bonds and molecular geometry. There is a video in which we have discussed molecular geometry, the shapes of molecules. And in this one, we will discuss the polarity of bonds. We shall have another video to discuss the second part of this lesson, the polarity of molecules itself. Let's have a look at the objective. At the end of this lesson, you should be able to identify polar and non-polar bonds and describe the relative degree of bond polarity. What is electronegativity? To understand bond polarity, we need first to have a clear understanding of electronegativity. Electronegativity is a measure of the tendency of an atom to attract the bond pair towards itself in a covalent bonding. When you have two atoms which are different, the bonding pair cannot be equally shared. It may even be equally shared only if their electronegativities are similar. If the electronegativity values are different, then the bond will be closer to the nucleus of one atom and a bit far from the nucleus of the other atom. And here it is very important to note that electronegativity is inversely proportional to the atomic size, to mean that when the size increases, the electronegativity decreases. And when the electronegativity increases, the size should be small. What is bond polarity? As I said, when we have molecules which are homonuclear, to mean molecules which have atoms formed by the same atoms, it means that they have same electronegativity values, and then the bonding pair will be equally shared. And that bond, we call it pure covalent bond. Let's take the example of nitrogen molecule. We have nitrogen, which is bonded to another nitrogen atom. So because the electronegativity of nitrogen is 3.0 and the other nitrogen is 3.0, then there is no electronegativity difference. And the two atoms have the same ability of pulling or attracting the bonding pairs. So because of that, the bonding pairs will be equally shared. So what happens when we have different electronegativity values, meaning when we have heteronuclear molecules or molecules which contain different atoms? For heteronuclear molecules, the bonding pair, of course, will not be equally shared. So it will be unequally shared. And in that case, the bond becomes polar. It's a covalent bond because there is that sharing, but because it is an unequal sharing, then the bond becomes polar. Why does it become polar? It's because if, for example, we have, let's say, carbon, which is connected or bonded to oxygen, bonded to another oxygen, the electronegativity value of oxygen is 3.5, that of carbon is 2.5. You can see we have a very big electronegativity difference. Very big electronegativity difference, showing that this oxygen, which is more electronegative, will pull the bonding pairs towards itself more than how the carbon atom can do that, because it is less electronegative than oxygen. So the bond becomes polar. And as we said, in a polar covalent bonding, the bonding pair is closer to the nucleus of one atom than the other. So in the example we have just given, the bonding pair will be closer to oxygen atom than carbon atom, because the oxygen atom is the one which has a stronger tendency of attracting the bonding pair towards itself. The greater the electronegativity difference means the greater the polarity of the bond. So if the electronegativity difference is very small, let's say that we have nitrogen oxygen bond, it's 3.0 and 2.5, and we have carbon oxygen bond, we have 2.5 and 3.5. So carbon oxygen bond is more polar than nitrogen oxygen bond, because the electronegativity difference here is 0.5 and here it is 1. So as the electronegativity difference increases, the polarity of the bond also increases. If the electronegativity difference increases, the bond will keep on becoming more and more polar. And at a given point, it will become ionic. At a given point, you remember the bond becomes ionic. Okay? So the more the electronegativity difference, the less the covalent character. We will see that using the simulation. And the more the ionic character of the bond. Here we have some data which can help us determine whether a bond is polar, non-polar, or ionic. Based on the electronegativity differences, the bond is considered to be non-polar if the electronegativity difference is between 0 and 0.4. The bond will be considered to be polar if the electronegativity difference is between 0.5 and 1.8. Of course, when we have non-metals, and it's ionic when we have the electronegativity difference, which is 1.9 and above, and with a metal combined with a non-metal. And here we have the charge distributions. The charge distributions here show that for chlorine, we have an electronegativity difference of 0. So the charges in the molecule are equally shared. We have similar colors all over the molecule. But here we have chlorine, which is more electronegative than hydrogen, and because of that, it's like hydrogen has lost, or it's about to lose its electrons. So we have the negative charges condensed on this side, the side of chlorine, while it's less on the side of hydrogen. It's the same with lithium chloride, which is an ionic compound with some covalent character, of course, but you can see the charges are condensed on one side, and on the other side, it's totally different. As the more electronegative atom attracts the bond pair towards itself, it becomes partially negatively charged. It gets a partial negative charge, and the other one, which is less electronegative, becomes partially positively charged. We take the example, we have carbon and oxygen. So this one will take a partial positive charge. It's about to lose, but it has not lost. And this one, it's about to gain, but it has not gained, because there is no metal here which can lose. Both are non-metals, so they should share, but they are sharing unequally. So they take partial charges, showing that they are about to gain or to lose. We have a positive charge here. It's delta positive, delta negative for the partial negative charge. And here we have the examples. Hydrogen fluoride. Hydrogen is less electronegative compared to fluorine, so it takes a partial positive charge, and the fluorine, which is more electronegative, takes a partial negative charge. Here we have a dipole moment for our bond. The charges are being pulled in which direction? Because this fluorine is the one which is more electronegative, so it is attracting the electrons. And the electrons are being pulled from hydrogen to fluorine. So we represent this by the dipole moment, which moves from the positive pole to the negative pole. From the positive pole, the less electronegative atom, to the negative pole, the more electronegative atom, which is pulling the negative charges towards itself. And then the pull is called the dipole moment. Now let's go to the simulation and see how the simulation works and how we can use it to illustrate how bonds may be polar, non-polar, or ionic. We start with two atoms. Here we will be describing the bonds, bond polarity, and for the molecule polarity, we will use the three atoms. So we start, here we have two atoms, atom A and atom B. This is how it looks when you open the simulation. And we can set the two atoms to have similar electronegativities. Atom A and atom B, they have similar electronegativities. And now we can call the bond pure covalent bond. It's non-polar. You can see here we have ticked the dipole of the bond, the dipole moment of the bond, but it is not there. Why it is not there? It is simply because we have a non-polar bond. Our bond is not polarized. So the bond is equally shared. When the bond is equally shared, the dipole moment of our bond should be zero. It will be zero. You can tick on the charges. The poles or the atoms will not be charged. If you put on the bond character here, you can see that the bond is more covalent. It is pure covalent. It is at the extremity of being more covalent. Okay? We put the electrostatic potentials. You can see that the charges are equally distributed. The charges are equally distributed, corresponding to the white here. And if you put there the electron density, even with the electron density, the charges are equally distributed. Now let's change this. We restart and we use atom A, which is less electronegative, and atom B, which is somehow more electronegative. You can see now we have a dipole moment. Let's put on the charges. Now, because the bond now is polar, we have different electronegativity values. Atom A, which is less electronegative, it carries a partial positive charge. And B, which is more electronegative, it carries a partial negative charge. Let us put on the bond character and see what happens. You can see the bond character here is between the covalent and the ionic. What happens if we increase the electronegativity of this atom B? You see, as you increase it, the dipole moment is also increasing, the partial charges are increasing, and even the bond character is moving towards the more ionic, or towards being ionic. Okay? We put there the electrostatic potential. Now look, the distribution here we have the positive and the negative. On the negative pole, we have a red color, and the positive pole, we have a blue color. What happens when we reduce the electronegativity? You see, the color is becoming pale. Why? Because the electronegativity difference is decreasing and the polarity of our bond is also decreasing. The bond is becoming less polar. This will be the same if we increase the electronegativity of our atom A. You can see what happens to the bond character. You increase because the electronegativity difference here now is decreasing, okay? Now let's have a look at the electronegativity, electron density. The electron density, when we increase the electronegativity to be more ionic or more polar, you can see the electron density is condensed to the side of atom B, which is more electronegative, which is having a stronger pull than to the side of A, which is almost losing the electrons, okay? And you can see still, you can see the bond dipole is becoming longer. It becomes longer as the electronegativity difference increases. It becomes small as the electronegativity differences decreases, okay? Good. The arrows here you are seeing, let's remove this. These arrows you are seeing here, they show that you can slide. You hold your left button of the mouse, you hold it down, and you can slide the mouse so it can move. But however you slide or you move your molecule, the polarity will not change. The dipole moment will not change. As long as the electronegativity differences are not changing, what you have will be the same, whether you change the position of the atoms or not. It remains the same. Again, if you want, you can reset and start from the initial point. Okay? So I hope you have understood how we can use the simulation, how it reflects and illustrates the polarity of bonds, how the electronegativity differences affect the type of bonding, the bond dipole, the partial charges, the bond character, the distribution of electrostatic potentials, and even the electron density. And remember, we are studying this because we will need this to determine the polarity of molecules, which is very important in determining several physical properties of molecules and substances. Now, if you are ready, we go to the quiz, and if you are not, you can replay the video to get a better understanding of what is bond polarity. Now let's go to the quiz. Now here we have the code of our quiz. It's VID 001015. Here we have the steps to take the quiz. You go to the website popanda.xyz. You click on login. The login icon is here. And after that, you go to take a quiz. And after you click on that, you get this window and you type the code here. VID 001015. And then you take the test created by your teacher. I hope you enjoyed the video. I hope you enjoyed the lesson, and you will be ready for more lessons.